DataOps Poland. Xavier, your turn. Welcome. Stage is yours. You can take the screen sharing.
Yeah, I still cannot see my screen there. I'm not sure if that's okay.
Yeah, I'm stop sharing. Yeah.
In theory, I'm sharing my screen.
And maybe try to once again to share it.
Okay, assume presenting. Oh, yeah.
Oh, yeah, it's good right now.
Cool, perfect. Thank you for that. So yeah, don't be sure. I cannot really speak Polish, so I'm going to do this in English. Thank you for having me here. It's super cool to to have the opportunity to speak about QuestDB. I really love databases. I've been actually working at QuestDB for a very little time. It's my first month in the company, but I really like what we are building at QuestDB. So I'm super happy that I could join. I work as a developer advocate, which means I basically manage the relationship between the technical community and QuestDB. So if you have at any point any questions, any suggestions, any feedback about QuestDB, feel free to reach out. Feel free to contact me on Twitter. You can see my Twitter there, SuperCoco9, also the Twitter of QuestDB. We also have our Slack channel that you can find at our website. We are super happy when we see people in the community speaking about things. So by all means, if you want to play with QuestDB, if you find any issues, you have any suggestions, really let me know. It's my job, literally. So you are not disturbing me. You are not, making me waste my time or anything. On the contrary, this is an open source project. So the more, the merrier. So yeah, what is this QuestDB and why I want to speak about this at DataOps Poland? So the first thing is like QuestDB is an open source time series database. And out of these words, I'm sure you understand a few of them. Open source, you know what it is. So, if you want to contribute to QuestDB, please feel free to contribute. The code base is in Java. So yeah, if you want to, but we have clients in different languages, but the code base is in Java. So if you want to contribute, we are super happy to have new contributors to QuestDB. It's a database and it's time series. And I know some of you probably are familiar with time series, but when I speak to developers, very often people are not really aware why we are speaking about time series, why we are building a database specialist on time series. Why is this different to working with a conventional database? So that's the first thing I want to talk about. So when we're talking about time series, the concept is very simple. If you have any timestamp in your database, and if you are storing data in a sequence, that's very likely a time series stolen. What I mean by this? Imagine a very simple example. Imagine you have some stock, like the Apple stock you see here, or a cryptocurrency. If you have crypto these days, sorry about that. Hopefully it will go back again. So, but we see a lot of people in the cryptocurrency world using QuestDB. Because of course, when you are working in any currency or cryptocurrency market, it's very important to keep track of changes over time so you can take an action. But it's not only for working with a stock or with currencies or with cryptocurrencies. If you are working with any kind of fleet tracking, imagine you are Uber or you are, Cabify or any of these companies, and you are doing car sharing or ride sharing. You probably want to track what is your vehicle at every time. You probably want to do analytics if the vehicles are going fast or slow, how many trips they are doing, those kind of things. But also if you are doing manufacturing, you probably have multiple machines. You want to do predictive maintenance. You want to keep track of different metrics, but also, of course, in DevOps. If you are working with different machines and you want to keep track of things like memory or CPU load or network, but also if you are in cybersecurity, imagine you are working in cybersecurity and you see an elevated rate of actions in a particular port. You probably want to detect that anomaly and react. But also if you are working on e-commerce, you probably are working on e-commerce and you have your customers are buying things and you want to track orders over time, maybe not just the orders, maybe also you want to track the page views, you want to see if a customer has been seeing multiple items of the same brand or category in a row, you want to analyze those actions. But also if you are working, I don't know, on streaming content, imagine you are someone like Netflix or similar, and you want to keep track when people is watching someone, the quality of what you are watching, or maybe you are developing a game and you want to do in-game analytics in which the players are taking multiple actions. In any of these use cases, you have something which is a common pattern. You have metrics or events that happen over time that you could put on a sequence. And if you analyze that data, you can make smart decisions. So that's the idea of time series. So time series is a type of database which is specialized on helping you working with this type of data. But why this data is different to working with relational database? Well, in a relational database, you are going to be, if you have a very popular application, I don't mean like a super popular application, like let's say, I don't know, Tinder or Snapchat or Amazon.com, the retailer, or Google.com. But if you have a popular enough application on a database, on your transactional database, if you are lucky, you are going to be ingesting a few hundred rows per second, and a few hundred rows per second, it's already a very large number. And you're going to have a few thousand reads per second in a very popular application. In an average application, you probably are going to have only a few inserts per second, a few inserts per minute, and you're going to have a few hundred or thousands reads per minute. But in time series, since we are tracking changes over time, usually the ingestion is super fast. Usually we get several thousands of events per second. You want to be able to query the data as quickly as possible. If you know about relational databases, if you want to query the data efficiently, you need to build some kind of index in order to do those queries. So in time series databases, you can query the data immediately after it has been ingested. And also time series databases give you a lot of semantics to work with data, which is tracking changes over time. So basically, with time series databases, you can do specific operations on your time series data. And in many cases, this is in exchange of being harder to query. If you have worked with some other open source time series databases in the past, maybe to your surprise, you've seen that they don't speak SQL. It happens a lot in the NoSQL data. You cannot speak SQL. So if you want to work with some databases, you have to learn a new thing. Well, in QuestDB, we speak SQL. So basically, when you ingest the data, then you can query the data directly with SQL. So we're speaking about a database which is fully open source, which is specialized on time series. I will show you in the examples what this means. And you can query with SQL. So if you already know SQL, it's very easy to start with. In particular, we speak the Postgres wire protocol. So most of the things that you are used to, to use in Postgres are already available in QuestDB. That means aggregations, that means joins, that means, of course, selects with filters, and all the things you are used to do in Postgres, you can do in QuestDB, but in a database which is specialized. And by the way, we are the fastest open source time series database. You can find on our website some benchmarks. I don't want to bore you with numbers, but in one of the benchmarks, we were ingesting over 1 million rows per second on a single machine. So it scales quite well. So we were ingesting over 1 million rows per second, and we were querying data at the same time in milliseconds. So the scale we are talking about is that you can work at virtually any scale. It also works if you have slow data. It's not only for fast data, but if you have fast data, we are actually very fast. This started by our CTO, Vlad. He used to work at high frequency trading. Also, our CEO was working with him for some things. And basically, in high frequency trading, every millisecond counts. So Vlad had some problems. He wanted to keep track of stock and price changes, and doing that with the tools that were available at the time, it was not enough. So he decided to create a database from scratch. Why not? He thought, hey, I can build the fastest time series database ever. And he was right. So basically, that's where we are coming from high frequency trading. So some things that are interesting before we actually start playing with QuestDB. By the way, I didn't tell you, but if you have any question at any point, please, by all means, interrupt me. I'm more than happy to take questions, as we speak. I'm going to be checking on the chat. So, you have any questions, feel free to write them down. I'll keep track. I'll try to answer them as they come. So basically, on QuestDB, the first thing is we don't really, when it comes to be fast, we are very fast because of different things. The first thing is, even if we feel like a SQL database, because we really think that's the way to go to be easy to use, we are actually quite different behind the scenes. The whole database has been built from scratch. And the first difference is we don't store the data in rows. We internally store the data in columns. You are from the DataOps group, so you probably are familiar with columnar storage. I don't want to bore you with that, but that means we can read only the columns we are going to be using. We also are time partition. When you create your tables, you can define the partition by time, and you can define the resolution of the partition. So when you are doing a query, we can actually scope the query to only the partitions you want to query and only the columns you need. And the way we work internally, all the data we store, it's stored internally as vectors, and they are sorted, so they are ordered by time. So querying the data for us is super quick. We don't need indexes. Actually, on QuestDB, we don't have the concept of an index because we write the data in chronological order. Until recently, until just a few weeks ago, we didn't support updates. If you wanted to update data, as it happens with other big data systems, you will have to insert a new row and do some tricks to simulate an update. But as of a few weeks ago, we released a new version. We usually release new versions every 2 or 3 weeks. So a few weeks ago, we released a new version in which you can actually do an update. And updates are not super quick because when you do an update, we need to do a lot of things behind the scenes, but it's possible to update, and we keep the data always sorted internally on disk. So it's very easy for us to do queries that are super fast. Not only that, but we have a lot of optimizations internally. For example, we take care of the parallel architecture of modern CPUs to be able to process multiple instructions at the same time. We do direct mapping from the disk to memory, so we don't have to be moving data around, and we can save milliseconds there. We are built, I told you earlier, that we are built in Java, but we are a bit special. We are in Java, but we don't use a garbage collector. We use only native memory, which means we manage the memory manually from Java. And that means since we don't have to use the garbage collector, we are consistent in our performance because we are never going to have an stop the wall event from the garbage collector. So we manage the memory manually. We don't have any dependencies. We built our libraries from scratch. For example, all the date parsing library is built from scratch to be way faster than other libraries in Java. So behind the scenes, there are a lot of optimizations, but actually what you see, it's a SQL database. That's how it feels for you. But behind the scenes, it's a completely different beast. That means for some things, you will find there are some incompatibilities. So I told you before that we speak the PostgreSQL protocol, and that's true. We support Postgres, but there are some things we don't really support. We are working all the time in adding more compatibility. But since we are really a completely different thing behind the scenes, some things will not be 100% compatible. You will see that many things you can imagine you're working with Postgres, and it works for you. But other than that, we are not online transactional database. So we support isolation, but we don't support, for example, multi-table transactions. We are built for a different use case. We are built for analyzing data for time series. We are not supposed to be the main database for your project. So if you are after a database which is highly consistent with transactions across multiple tables, we are not a database. We are for time series analytics. So that's, just to be extra sure. As I told you, even if we support deleting partitions and we support updating right now columns, we are not optimized for that. We are optimized for the use case of inserting data and reading data very fast. So deleting and updating, it is possible. It is just not as fast. And also, we are not a data lake. We are specialized to work with fast-moving data, which fits into a database model. That means we don't support every kind of arbitrary, for example, binary columns. We are not specialized in working with data from multiple places. You basically ingest data as text or as JSON, and that's about it. So we are a database which is specialized on time series analytics, and we are not trying to be any other thing. We have integrations with many tools. Since we speak the process protocol, we actually have automatic integration with many different tools. For example, if you want to do real-time dashboards, you can use Grafana with the Postgres driver, and it works out of the box. If you want to work with Kafka, I believe a few months ago, you had the people from Red Panda actually speaking about this. So you have Kafka. You can also, write very easily into QuestDB. You can use TensorFlow if you want, Pandas, and pretty much anything from the Python ecosystem. For ingesting data, apart from being able to ingest data directly with the Postgres protocol, we have a RESTful API, and we also support the influx line protocol, which is a binary protocol that allows us to ingest data very quickly. So we have a lot of integrations, and we are working to have more integrations. I'll show you now in a second some of the things we are going to be, I'm talking about some of the integrations. So just before I finish speaking, and I actually start doing the demo, I can see here I have a question from Simon Calabrese. From the Git repository, you can see C code, but only Java. We are mostly Java here. That's the situation. We have also a few other things. We are, apart from the open source product we are building now also the QuestDB Cloud, which is basically a hosted version of QuestDB in which we manage the installation for you, so you can forget about operations. For that part, we are also building things with Python and with JavaScript, but that's not really part of the core of the open source core. But yeah, it's mostly Java. What you see as C code in the repository is just marginal. So the main part of the code base, and if you want to contribute, Java is what you're going to be finding. So in terms of what we're going to be building,
I just unmute myself. I have some other questions, but
sure.
I will do it after yours. No, continue. Sorry.
By the way, if we have short break, Simon is one of our presenter, if I remember correctly, right, Simon?
Yeah, that was like 1.5 years ago.
Okay, yeah, exactly. So nice to see you once again. Okay.
Now, the thing is to expand Pei, by the way, Pei is my colleague. She's fantastic. She's been at the company much longer than myself. So yeah, she's saying that, C and C++ are mostly for low-level optimizations. But the thing is, the way we are working with Java, we, as I told you, we're using Java in a very unconventional way. We don't have any dependencies. We manage the memory in a native way. So the cool thing about Java is that it allows us to build the binaries in a way which is compatible with multiple platforms. If you do this, if you do the same with C and C++, compiling and cross-compiling for multiple platforms is actually a pain. And when it comes to optimizations, since in Java you have the hotspot in the JVM, it's actually very performant. In many cases, it's comparable. So except for a few things in for low-level optimizations, we really prefer to have most of the product in Java because it's easier to work with, and it gives us the comparable performance. So that's why I was mentioning only Java, because that's what we prefer in terms of the code base. So a few things we've been releasing lately. Until recently, if you had data that was coming out of order, by recently I mean the past few months, if your data was coming out of order, you didn't have a good way of dealing with that. And in QuestDB, it's quite important that your data is in order physically on the database, because if it is not, we cannot do a lot of the optimizations. So we support now out of order ingestion. Basically, this means that if you have data that is going to be coming late out of order, because maybe you are getting data from devices and you have network latency or jitter or any lag or something like that, you can configure how often we are going to be committing to the disk. You can also configure which is the expected lateness of your data, and we can make sure even if your data is coming late, we can still rearrange and write in the right order on the disk, so your data is going to be easy to to be accessible. We just released updates just a few weeks ago. We are going to add high availability soon. Is one of the number one requests we are getting, because right now QuestDB runs on a single machine. If you want to do high availability as of today, there is not a good way out of the box. You can always do things, but it's not an out of the box solution. So we are working with on replication and high availability, and we hope to have something in that area soon. And as I told you, we're also launching the cloud solution, which cloud is not going to be open source. Just to be extra sure, the community version open source, what we have right now, that's going to be always open source. But on cloud, we are going to give you managed operations. So you don't have to worry about things like, I don't know, like doing your backups, or about, scaling, or about configuring the database, things like that. That's going to be on us. So that's going to be the commercial part of the product, but everything we have in open source is going to be open source. We have an Apache 2 license. We are super permissive with the license. You can use it for absolutely anything you want. You can, if you want, use QuestDB to build your own cloud and be our competition. That's totally fine. So, the open source community, it's open source, and to us is as important, if not more, than the cloud solution we are building.
Okay,
So,
I have a few other questions if I can.
Yeah, of course.
One is related to the programming language. I'm a Scalist. I mean, I'm a big fan of Scala. So my first question is, why you consider Java and not Scala or Rust? Because I'm one of the contributors of Delta. And for me, the first pain was that it's written in Rust. But looking at it, I also understood why, because it's really lightweight compared with Java or also with Scala. Why did you not consider it? It's just mainly related to skill set?
Yeah, that's a good question. And I'm not the person who, I'm not Vlad, who is the one who took the decision originally. But I believe it was a mix of, of course, knowing the language, but we are not really using that much of Java itself. But it's also about the ecosystem. In Java, you have a very rich ecosystem. You don't have exactly the same ecosystem in C or in Rust. So compiling, cross-compiling, continuous integration, all those things are important. So we wanted to have a good speed of development. And in Java, we can actually do that, even if we do Java in a very unconventional way. So I believe the main motivation was having the right tooling around the language and portability, which is why Java was chosen. But I don't have any more details. That's all I can tell you. I'm happy to to ask Vlad if he had like any other insights, and I can get in touch with you any other day. But yeah, as far as I know, it's because of the tool chain and because of portability.
All right, thank you. And the last one is about the connectors. I see TensorFlow, and I also assume that actually I thought that as a first connector that you might consider was also Spark or Flink, especially for streaming. Have you considered them already?
I did a presentation on Apache Flink just last week. So with Flink, something you can do is you can use, as of today, you can use the JDBC connector to output from Flink into QuestDB. Just in case people are not familiar with Flink, Flink is very similar to Spark. It's a framework to work with batch and streaming data. I believe they call it a unified framework for batch and streaming. So basically, you get data from a number of sources. You run transformations on those data sets, and then you output the data to destinations. In Flink, they are called sinks, and you have connectors for those things. It's open source. So yeah, you can use the JDBC. There is a JDBC connector, and that one works for QuestDB. I was actually using it. With JDBC, we have some issues because if you are doing concurrent writes on JDBC, you are going to be some contention, some logs. If you use the influx line protocol, you are not going to be getting any logs. With JDBC, you are going to be getting that. So on Flink, since if you are scaling much, you want to parallelize, using the JDBC connector wouldn't be the best option. But to the best of my knowledge, there is also an influx compatible connector for Flink that I still haven't tried out. But we speak also the influx line protocol. So as long as you use the influx line protocol connector in Flink, you should be able to write directly to QuestDB. And same thing with Spark. If you can write to JDBC or to influx with Spark, you can configure. You only have to change the port and the endpoint to point to your QuestDB installation, and it works out of the box. So for ingesting data, that will be the easiest way. So we don't really need to create connectors for many tools because the connectors are already there. If you have JDBC or influx, you can directly write data into QuestDB. Does it make sense?
Yeah, sorry, I answered you on chat about the JDBC approach, because especially in Spark, if you have time series, might resolve in bottleneck.
Yeah, it can be a bottleneck. The other day on the demo I was doing the other day on Flink, I had JDBC and I was ingesting something about I believe it was 100,000 rows per second, but that was getting close to the limit of what I could be ingesting at the time. So 100,000 rows per second, which is not too bad. But yeah, depending what you are doing, it could be an issue. But with Flink in particular, with the JDBC connector out of the box, 100,000 rows per second, I could ingest that without any issues at all. So I don't know.
Okay, yeah,
let's move forward, okay?
Sure. Darius, I have here, how fast is a process of searching for latest data? Do you have to read through all the partitions, have a benchmark? Yeah, I'll show you, Darius. So it's easier if I show you that if you ask me, but basically searching is super fast. We typically get results in milliseconds. We don't have to go through all the partitions. We only have to go over the partitions that you have in the query. And since we are sorted, that's quite quick. The only thing is we have a time since you send the data until we commit the data. There is a lag there, and that's configurable. You can configure how long your data is going to be waiting to be committed. And you can configure the maximum number of messages pending to commit or the maximum time. And that's also related to how we deal with out-of-order data. So you can change the configuration to define how often your data is going to be committed to disk. the moment the data is committed to disk, it's immediately available for querying, and queries happen in milliseconds. If you are using very complex aggregate functions, then it's going to be seconds. But for regular queries with just cheap aggregation functions, it's going to be milliseconds. So it's super fast to consume data. But yeah, Pei shares some benchmarks with you on the chat. Thank you, Pei, for that. But yeah, that's about it. But I'll show you now in the demo. So we have some extensions, and actually I'm going to show you these extensions right now. So you'll see how they work, because I want to have time to work on the demo. So if you think it's okay, I want to stop speaking and I want to start actually showing you what you can do in QuestDB. So let me just get out of the this browser, and let me just see for a second where I have this. So the first part, in case you wanted to follow, I don't know if you want, but if you want to follow, and if you have a laptop with Docker, you can actually follow me on this. I create here a gist, and what I'm doing here, basically, I'm just replicating what you can find on our getting started. So the first part of the demo is just for you to see that it's quite easy to get started, okay? And then in the second part, I'll be doing some more advanced queries.
Can we share? Sorry, can we share the link on our chat? It will be much more easier because
I believe it is already on the chat.
Okay, thank you.
Hopefully it is, yes. There is a gist there. So the first thing is, if you have Docker, you can just start playing with QuestDB, just doing Docker run. If you don't have Docker, you have the binaries. QuestDB works in Linux, in Mac, and in Windows. If you want to work with the binaries, you have the URL. If you are on Mac and you prefer to use brew for installing, you can just do also brew install QuestDB. It's in the same link in the documentation. So, but for me, I prefer Docker, because Docker it makes super easy to start with, so you don't have to worry about anything much. But yeah, it works in Windows, it works in Docker, on Mac, and it works on Linux. On Mac, I have an M1, and also on the M1 with brew install, it works out of the box. So the first thing you're going to notice is, I'm going to make this a bit bigger. Sorry about that. So the first thing you're going to notice is I'm opening a few ports. If you are running locally, you don't have to worry about this. In Docker, I'm just opening a few ports. And these ports basically are for the web interface, for the REST API, for the Postgres protocol, and for the influx line protocol. That's the idea. Okay. So the web interface is going to be at port 9000. So, and of course, if you have Postgres command line, you could connect with your Postgres command line client. You could connect to QuestDB and use this. You can use Jupyter. I'm going to be using Jupyter later. But once you have started your instance, if you are on Docker, you're going to find this. In your case, the tables will be empty. In my case, I have some tables that I already created, but you have a web interface in which you can do a number of things. If you want to start very quickly, one thing you could do, we're not going to do that right now, but you could just import some CSV. So if I had you had like some CSV data here on your locally, you could just import some data. So in my case, I just imported some data, okay? But we are going to do something a bit more interesting. In the same gist that I share, we are going to be issuing some commands. So if you are running with me on QuestDB, let me just move this out of the way. So I'm going to put, okay. So I'm going first to create a table. So yeah, I just created a table called sensors. And the table, as you can see, it has just an ID, a string, and a city. Easy enough. And now I'm going to be inserting some data. We have some functions which are interesting for creating for generating data synthetically. If you want to simulate data, if you want to create fictitious data on your tables, we have good documentation about that. But in this case, I'm just going to be adding, the ID is going to be auto increasing. Then we are going to have a random string out of these values. And I'm going to insert 10,000 records with this kind of random values. So
sorry, could we have the left window slightly bigger?
Sorry, yes.
Oh, yeah, great. Thank you.
About that. So let me just then change a little bit my better. So now if I, of course, I can do just tell me how many, I cannot type, but that's fine. How many rows I have in sensors. It's going to tell me that I have 10,000 rows, which makes sense. So if I follow my gist, I'm going to create a second table, and this one is slightly more interesting. In this one, I'm doing a create table as select, so with the result of the select. And again, I'm just using some random data, and I'm partitioning by month and indicating that this particular column, the column TS, is the timestamp. When I indicate a column is the timestamp, this is giving the indication to QuestDB to order physically the table according to this particular column for the optimizations. So once I execute this, I'm going to be creating, I believe it's 10 million rows. So I'm going to be creating 10 million rows. Yeah, if I execute 1, 2, 3, 1, 2, 3, exactly, yeah. So now I have 10 million rows. So now, so far, it feels pretty much like any other SQL database. And I can do things that I will do in a database, nothing too fancy. Just, if I do the average, it works. If I want to do something a bit more interesting, like just joining data between, my readings table and my sensors table, that's going also to work. So I can just execute, do a join between one and the other. And of course, I can do things like, I'm just using here, like what's the maximum temperature. So, so far, nothing too interesting, but we can start doing interesting things right now. I can do things like this. I can do right now a select, joining from, a subselect. And I actually have this thing where the timestamp is in, for example, this. When the timestamp is in this particular date. So this is going to show me all the data that is in this particular date. If you were working with a conventional database, you probably don't have this type of built-in functions for dates. I can do something better. I want to read all the data in 2019. That's okay. Or all the data only from January. That's fine. Just execute the query again. I don't have any data from January, apparently. So I'm going to read the data only from October. Okay, in October I have data. But from October, I want also the 20th of October. That's fine. I could actually do things like, oh, but I want the 20th of October at 10 in the morning. You see the thing, yeah? So I can go down to microseconds. So I can put here the timestamp I want to have here, and I can do even more interesting things. I want to have from the 20th of October and also another 5 hours. This is going to be 20th of October and 5 hours more. So this is some of the things you have on a time series database. You have extensions for actually working with time. Yeah, you see the idea? Oh, I have here a couple of questions. Simon was saying, or Simon, I'm not sure about the pronunciation, sorry. So Simon or Simon is saying, so we you do support UDTFs. I'm not sure if you are referring to user-defined functions.
Yes, user-defined table functions, like a
Yeah,
function
so
that...
we still don't have user-defined functions. It's something we have on the roadmap. So on the roadmap, we have two things actually we are thinking about, which are user-defined functions, but also having some way of sending, of scripting the database with Python, similar to what you can do with Lua on Redis, for example. So those are still in the roadmap. We are still not actively working on that full time, but yeah, we are on the definition phase. We are still considering what's going to be possible. So as of today, we don't have UDFs, but in the future, that's something for sure we're going to have. We are still defining how that's going to work. Okay, but yeah, right now that doesn't work. Okay?
What I mean is that actually you have something like a user-defined table function, because it's like the one you use for sequences, long sequences in the first indication, in first instruction.
Yeah, but that's part of the database. It's not it's not defined by you. You cannot really define new functions. You can only use what we offer right now.
Okay.
Okay. So if you want to define your own, you have to wait. So hopefully soon, but I don't know exactly how soon, because we are still working on that. But yeah, it's something on Slack. It's been requested several times, and it's something we want to actually support at some point. Okay. So I don't know if any of you have been following some of the queries, trying to do something. Did anyone try to follow or not? It's okay if you don't. It's just, you see, when Thomas told me about this, I believe he mentioned something hands-on. So I wanted to make sure you had the opportunity. So if someone was following and you had any issues, let me know, because for the second part of the demo, I'm going to be actually doing things on my own machine, because I'm going to be working with larger data sets and with more complex queries. But for this first part, I just wanted you to see that it feels like just like SQL. So we were just creating tables, we were ingesting data, we were doing queries with joins, with some extensions, for working with time. But we didn't do anything that wouldn't feel like SQL. Okay. For the second part, I'm going to show you something slightly more interesting. We still have about 13 minutes or so before I have to wrap up. I'm not in a hurry, by the way. You have more questions, I'm happy to stay longer. But yeah, in the next minutes, I want to show you a bit more interesting things. So the first thing I'm going to do, I'm going to be loading. Let me just move my screen here. So the second thing I'm going to do is I'm going to be loading some interesting data. I have some data here. I'm going to make this bigger.
So, yeah, sorry for interrupting. Yeah, if you would like to show something. Yeah, exactly. Now it's much more better. Thank you.
Thank you. So yeah, so I'm going to show you just data set I have here. This data set, by the way, I generated automatically. There is an open source project, TSBS, which is for doing benchmarks on time series databases. And there is an extension to create and ingest data into QuestDB. So I just generated yesterday this, this data set. It has 28 gigabytes of data. So it's basically, I'm going to be generating simulated data for 500 vehicles over 3 months with 1 minute resolution of different metrics. In total, as you see, is 28 gigas of data. So I'm going to be ingesting this data as we speak. So my machine has 8 CPUs. So I'm going to tell QuestDB to load this data in parallel using all the CPUs. But of course, I'm doing this while I have multiple tabs in Chrome, while I'm doing an online session with you. So it's not going to be super fast, but still, you will see it's fast enough. So right now, if I check here, it will be created, it's creating 2 tables, one with diagnostics and one with readings. Okay, so let me just show you how many columns we are ingesting. So if I do a count from the readings table, this is while we are ingesting data, okay? So right now I have, how much is this? almost 12 million, now 14 million, now almost 15. So if I click, if I keep updating every few seconds, you see here, yeah? So it's 17 million, 18, 19, not too bad. With on a just personal laptop with a lot of things going on, with an online session. That's kind of the idea. So I'm ingesting the data. It's going to take a while. It's going to take about 3 minutes to ingest all the data. But I don't want to have you for 3 minutes actually waiting until this finishes. So let me just go. I have to find where I have my other tab. Here it is. So let me just show you what I'm ingesting here. By the way, we have now 30 million, so we are still. So let me just show you a little bit of the data. This is what it looks like. I'm ingesting this kind of data. I have multiple tracks. They are like, which fleet, which driver, which model, which version of the device, and multiple metrics. The capacity, the fuel, the consumption, latitude and longitude of the vehicle. We are getting resolution every minute. So here you can see all of them seem to be in the same minute and differently millisecond or microsecond, but you see the same minute because basically we're ingesting from multiple tracks. But if I focus only on one particular track, if I do, okay, I want to show this only for the track with the name, for example, track 110, 11. Sorry, where? Oh, yeah. I have this. I have the word on the wrong place. Sorry about that. So if I execute this now, you can see here, I get data, every minute I have like a new data point, okay? So that's basically what I have. We're still ingesting data, that's fine. So let me see how many rows I have already for this particular vehicle. I have 100,000 rows for this particular vehicle. And of course, I can do more interesting things. I can just do things like, okay, let me show, I want to show, to see, sorry. First, let me do this without anything. So I'm going just to do select the timestamp, maximum, minimum, and average for this particular track. You will see I'm not using a group by, and this is because we have some SQL extensions, and when you have aggregates, we don't really need to use a group by. We do the group by automatically because, since we are built for analytics, most of the time you are going to be doing a group by. So basically here, you can see we are grouping by timestamp, which is not very useful because, its entry is a different timestamp, but we can do something interesting. We can do things like, okay, I want to sample the data by 1 hour. I told you we have the data by minute. Actually, first I'm going to be aggregating by day. So I'm going to be aggregating by day. And if I execute this, we are sampling the data by date. So here I'm saying the maximum velocity, minimum velocity, and average per day. So you see here the timestamp is January 1st, January 2nd, January 3rd. Yeah? I could actually do by, by minutes. I could do by hour. You could aggregate by microsecond, by millisecond. We go down to microsecond. Okay, that's how we roll. So in this case, I'm doing the average per hour. Oh, by the way, this just started. I just finished ingesting. It was slightly over 3 minutes. We were ingesting only 700,000 rows per second, which is not too bad. So if I do now count how many rows I have on the database in total, let me just, so we have, yeah, I believe this is not right, this number. Oh yeah, this is, so we have 6, let me just for a second to check the second table, diagnostics. diagnostics table. So yeah, we have now about 58 million rows on each table. Okay, so one in diagnostics, one in readings. That's kind of the idea. So let me just show you again some cool things we can do. Apart from giving you time series functions, we have some specialized functions, for example, for working with distance, because on time series is very often the case that position is important. So if you have latitude and longitude, we have very basic. We are not PostGIS, okay? We have very basic geographical functions, but we have some geographical function, and one of them is, for example, getting the Haversine distance. So in this case, I'm going to see in these 3 months how much distance we had in this particular track. So we have 45,000 miles, and I can combine this with what I showed you earlier. I can do things like, okay, tell me how much distance this track did only in January of this year. So 45,000 was for the first 3 months of the year. So only in January, it was, it was for 15,000 miles. It's like, you know what? From January 1st, I want to count the next 45 days. So this is going to give me how much distance it did in 45 days. So as you can see, interesting extensions for working with time series. Something that I still didn't show you is that you can do also things like, let me just for a second copy one of my queries here. We can do things like this. I can do things like I showed you before already. Just select the timestamp and the average velocity and sample by 1 hour. But something I can do, which is totally interesting, I can automatically plot this here. So I select here my time column. In this case, this is the time column. I select here which series I want to display. I'm only tracking one parameter here. So I can just draw here. I can see this is too much. So I'm going to limit only to 1 week of data. So 168 hours, which is 1 week. So this is, I'm going to put this as a line. So this is directly on the web interface, okay? On the console, you have a way to do simple visualizations with your queries, which can be interesting. But the cool thing about the time series database is that when you combine all those things, you can start doing interesting things. For example, what if I want to check the average speed of one of my vehicles with the average speed of one of my other vehicles? Something I can easily do, and easily, it really depends, there are different ways of getting this, but something I can do is that I can join my table filtering with one vehicle. Let me show you here the query. So I can join my table with a subselect for the track 111, a second query for the track 110. I'm going to do the average of both of them. I'm going to be getting the timestamp. I'm going to be aligning the timestamp to natural days. So I can join now the first subselect with the second on the date. So basically what I'm doing here is I'm doing a subselect of all the data I have for the vehicle 110, all the data for the vehicle 111, sampling the interval to 1 hour resolution. I could go to 1 minute, to 1 day, to 30 minutes, to whatever I want. And now I can compare both of them. And actually, if I show this visually, it's going to be easier to see. So basically here, what I can see is the visual comparison of the velocity of my vehicle with the other vehicle. Of course, you could do this without a time series database. Just the query wouldn't be as simple, and probably it wouldn't be as fast. Remember, we don't have any indexes. We are not doing anything special. We are just running queries on data we've been ingesting very quickly, 700,000 rows per second, and we are just querying the data almost immediately without any issues. Are you still with me here? Because, by the way, I lost the window. Oh, here it is.
Yes, yes, we are here.
Thank you. Is there any shortcut for query auto format? Philip, that's a super good question. And maybe it is, but as I said, I think using QuestDB for a bit, but actually I've been part of the company only for a few weeks. And if there is a shortcut for formatting, I still don't know it. So it might be the case there is one. I don't know if there is one for auto format. Sorry about that. But I'll make sure if I find there is a shortcut for auto format, I'll comment that on the Meetup group just to be sure you get the answer. But you get the idea, yeah. You can do here interesting bits. Can you get these queries automatically into Power BI? Yes. I don't really like much things like Tableau or Power BI. Power BI, to be completely transparent, I haven't used it. So I've heard good things, but I haven't used it. But I'm not a big fan of things like Tableau or things like on Amazon QuickSight, for example, or Google Data Studio. You can integrate with them very easily because you only have to connect with the Postgres protocol. If you go to our website in the tutorials, you have some tutorials to connect, for example, Google Data Studio with QuestDB. It works, but they are not built for real time. So I personally prefer to use Grafana for those things because Grafana is really for real time. I don't have right now the Grafana configuration handy here, but I can show you actually. I can show you one of the other day I was doing a demo, as I told you, with Apache Flink, and I have here a short video of my Grafana panel. So this was just, I was ingesting at this particular example, I was ingesting about 100,000 rows per second, and I only had to connect with the Grafana Postgres driver. If you go to our documentation, we have a tutorial how to connect with Grafana. All you have to do is connect with Grafana, localhost, the port where we are listening, and the only thing you have to make sure is that you disable SSL authentication because we don't support SSL authentication right now. So you have to disable that, and then then you can work with Grafana the same way you will work with any other database. So that's about it. It works out of the box. Many of the business intelligence tools, they work out of the box. Some of them, like for example, Apache Superset, they don't work because we are compatible with a lot of the Postgres protocol, but we are not compatible with all the meta queries you can get in Postgres. We are working on that. Our CTO is these days working in supporting more parts of the Postgres dialect. So we are able to connect with more business intelligence dashboards, but things like Grafana works out of the box. Things like Redas work out of the box. Things like Google Data Studio work out of the box. But there are some tools you will find. If you use, for example, DataGrip as your ID for databases, it also works. So there are some tools that work out of the box, some tools that have some issues. We are working to prevent those. If you find any tool that you are working with which is not compatible with QuestDB but is compatible with Postgres, let us know. I will you can just fill an issue on GitHub and we'll be happy to take a look and try to make it compatible. Okay.
I have a question.
Sure.
It's more about like comparisons. So it looks really a valid alternative of Prometheus, no? Let's say for time series, but let's say more SQL-ish. But there is one feature that Prometheus has really important that is about alerting and notification. Do you have a system, or have you planned to have a system, for example, to generate events like mail or notification if some time series change? Let's say if I want to check stocks and I don't want to use all external products, can it be something on your roadmap, this feature about, for example, alerting with continuous queries?
Yeah, that sounds interesting. We don't have that right now. We are not a monitoring solution. We are a time series database. So our use case is being the fastest, most efficient, developer-friendly time series database. So as of today, if you want to have alerts, one possible solution is using the alerts you have on Grafana. actually in our documentation, the tutorial for Grafana. It's a tutorial in which you set up Grafana, you connect Grafana, and then you define the alerts with Grafana. So out of the box, that's the what will work today. Actually, we export metrics to Prometheus. So just using Prometheus for monitoring, you can monitor QuestDB with Prometheus. That's supported, okay? But we are not a Prometheus substitute. We've been speaking, and we are still at not decide if at some point we are going to work into being, there's been some conversations, but at some point we were speaking if it would be interesting for us to work in QuestDB to be an alternative to the Prometheus backend. So you could use the Prometheus interface with QuestDB behind the scenes. But that's a conversation which is ongoing. We are still undecided. But we are not looking into replacing Prometheus. We are not looking into building an alerting solution. Continuous queries that have a different thing. So we had some users on the Slack channel in the past and also on the GitHub issues that have been asking if we will support continuous queries or maybe a scheduler built in QuestDB. And those are open right now. So we are still considering if we're going to be working on that or not. In any case, it's an open source project. So, if enough people wants to build that, should be possible to do this. As of today, I believe we have something about 5,000 contributors to the project. So, which is larger than the company size. So basically, we have a healthy community. But yeah, we are not thinking, the core team right now, we are not thinking of replacing Prometheus or building an alerting solution. Okay?
Yeah, sure. Thank you.
Yeah. But really appreciate the questions. Super relevant questions. So I'm super happy that, by the way, you are asking those things. The last query I want to show you before I show you just another integration and then we wrap up if you are good with that, is that before I show you a query for the distance with latitude and longitude, now I show you a query with comparing one vehicle with the other. So something I did here is I compose a query in which I'm selecting both the average velocity and also the distance that a vehicle is traveling every hour for vehicle 110 and 111. And if I run this is going to be slow because the function to calculate the distance is not super fast. So it was faster than expected, but probably it's coming from the cache because I was executing this earlier. When I execute before, it took about 20 seconds. So I don't want to, to give you the wrong impression. So this took about 20 seconds before. Now it was only 4. It's probably caching issue. Okay, so it was faster than expected. But here what I can see is the velocity of the vehicles and the distance they travel per hour in the past week, which again is quite cool. And yeah, if I wanted, I could just put this directly on a chart. As you can see here, I'm going to just take out the velocity and leave only the distance. So yeah, that works out of the box. So for the last bit, just for you to see that this is easy to integrate with other things, I just want to super quickly show you where do I have my, here it is. I was trying to find in which browser I have this. So I have a Jupyter notebook that I started, Jupyter. Yeah, you are DataOps Poland, of course you know Jupyter. In case you don't know Jupyter, in case someone, let me just see. So in case you don't know Jupyter, it's just an environment in your browser to work with Python, also with other runtimes, but very usually with Python. So what I have here is a Jupyter environment. Let me just see again where I can have my environment. Here it is. So, okay. So I have a Jupyter notebook here in which I created a super simple, notebook. It comes also straight from our documentation. In this case, I'm not even using the POSIX protocol. I'm just using the RESTful API. So I'm just importing the request API and just issuing, a REST call to create a table. So yeah, it's giving me an error because the table already exists. So now I'm just ingesting some data. So this is just Python, like, I'm just generating data. I'm just calling insert over HTTP. I could do the same using the Postgres connector. I can then just query the data, and I can use pandas if I want, of course. A thing about pandas is that pandas is super cool, but you need to host the whole data set in memory. So a cool thing about QuestDB is that if you're using pandas, you could issue a select on QuestDB to load only a part of the data, or to run aggregations, or maybe sample the same way I was sampling per minute. Maybe you want to sample per second, or per minute, or per hour, to make the data set more compact and fit in memory. So pandas and QuestDB are actually pretty good friends. And yeah, I can pretty much, do anything I want on a notebook with Python. And to make things a bit more interesting, I have here an example with scikit-learn, because I know sometimes at this group you also speak about machine learning. So again, what I'm doing here, I have a data set in which I have a few rows, and rather than loading the whole data set, I'm going to load only a subset of the data. So I'm going to be running a query in QuestDB in which I'm going to be getting the data in which anomalies are 0 or 1, nothing in between. So I'm executing this query on QuestDB. What I'm doing now, I'm just transforming the data a little bit. So basically, from this data frame that I got executing the query, I'm going to be removing one of the columns because I don't like it. I'm going to be converting some column to integer. I'm going to be creating a different array. And in the end, I'm going to be getting the transform data ready to train. So in this case, I'm going to be using BERT, which is one of the algorithms in scikit-learn. BERT can be used both for clustering and for anomaly detection. So in this case, I'm going to tell BERT, the model, that I'm going to be training on my data, and I'm going to have two clusters, one for the normal data and one for the anomalies. That's kind of the idea. So I'm going to create two clusters, and I'm going to just fit the model. I have only a few thousand rows, so this is going to be super fast. So as I'm going to be training the model. So yeah, it already trained. And now I'm just going to be plotting the confusion matrix to see, how I'm doing. Actually, the prediction is not super good. I'm only getting about 40% of the anomalies. So the model didn't perform very well, but probably it's because I don't have enough data. Okay, but I'm not here to show you how you can do fantastic predictions. I'm just here to show you how you can incorporate QuestDB into your regular flow if you are doing machine learning. So, more or less, this is what I wanted to tell you today about QuestDB. My plan was I'm trying to find what I have my presentation, the original presentation I was doing on Google Drive. But yeah, anyway, that's basically what I wanted to show you. I wanted to help you understand a little bit, if you didn't know, why a time series database is interesting, what is QuestDB, why we think we are building something which is cool, some of the extensions for time series, like working with time, being able to align and to sample and to join multiple tables by time, how fast it can be to ingest, how easy it is to integrate with other platforms, and of course, all the questions of Simon that were super cool to help me tell you more interesting things. Simon is telling which authentication level we support. So right now, for authentication, we are still working on an authentication model. We don't have, as of today, authentication and authorization is not on QuestDB. So if your endpoint is exposed to the public, that's about it. The more we can do, we offer you to have a user only for reading or only for writing, but we don't have any authentication or authorization. We are right now, our team is working on that. It's one of the things we hope to have soon, to have some level first of authentication, in the future also authorization. So at the beginning will be just for logging in, and then in the future also for other more interesting things. So yeah,